Manegri sir.
Yes.
Manegri sir.
हाँ बोला.
Start.
Start करो. Very good afternoon to you all. On the behalf of Department of Civil Engineering, Mechanical Engineering, I would like to welcome our guest speaker Vaibhav Patil sir, Region Head Tech Flow Goa. Then I would like to welcome our Principal sir J. Bhosle sir, Principal of Yashwantराव Bhosle Polytechnic Sawantwadi. PP Sawant sir, HOD of Civil Engineering Department. NV Salve sir, HOD of Mechanical Engineering Department, PD Kade sir, HOD of Computer Engineering Department, Mr. Milind Desai sir, Training Placement Head, and I will also welcome to faculty members of Civil, Mechanical as well as all the students for today's webinar. Our college has been established in the year 2014 with civil, mechanical, electrical and computer engineering program. In year 2018, our college was awarded Indian IST Best Emerging Institute Award. As well as we are also proud to have received NBA accreditation for civil, mechanical and electrical engineering program in year 2019. In today's webinar, we will learn about the advanced software which will be used for designing of a steel from Mr. Vaibhav Patil sir, who works for TechFlow India Private Limited in Goa. Now, I would like to request our principal sir to address the audience.
Thank you, Manirikal sir. Welcome and good afternoon to all. Myself, G.A. Bhosle, Principal, Yashwantराव Bhosle Polytechnic Sawantwadi. I welcome all of you for once again for this webinar, Advanced Software for Structural Steel. Executive Chairman, Honorable Achyut Bhosle sir, for giving us permission to conduct this webinar. All of you know, due to the COVID-19 outbreak, learning process, it becomes very difficult to conduct the classroom teaching. Also don't know the starting of colleges in full strength also. Therefore, we have decided to conduct the webinar on the advanced software for structural steel detailing. Definitely this webinar is useful for civil engineering as well as mechanical engineering students as well as the faculty members conducting on advanced software for structural steel detailing. And for that, we have got the resource person and expert in this field, Mr. Vaibhav V. Patil, Region Head, TechFlow Private Limited, Goa. So without taking much more time, I request to Manegri sir and faculty members. Thank you.
Thank you, sir. Now I will give the introduction of today's guest speaker. We have very thankful Mr. Vaibhav Patil sir, who has worked as a region head in TechFlow India Private Limited. Sir has a 13 years working experience with TechFlow India Private Limited, Goa. The company TechFlow Engineering Private Limited has emerged as a global leader in detailing zone, as well as company has been breaking the boundaries of geographical limits and developing at a lightning speed. The TechFlow hold 200 of a Telca BIM software license as one of the largest user of a Trimble solution globally. The company is specialized in steel designing, structural designing, and connection designing. So I would like to request Patil sir to commence the session.
सर तुमचा आवाज येत नाही.
Sir, audio unmute करा.
Thank you, sir. Myself, Vaibhav Patil. We will just start with the steel detailing and the what software used to make it. So I will show you as a slide or the PowerPoint presentations to understand this. Yes, now we can start. The concept of structural steel detailing, importance of structural steel detailing, where structural steel detailing is required, steel detailing procedure, and steel detailing software and applicability. So what is steel detailing? The steel detailing is a preparation of shop drawing from the structure and architectural design document. So initially what happened, we got a structural and architectural drawings, which is like plan elevations that not normally we did in all Indian buildings, but that structural steel detailing is always and mostly used in America, Canada, Australia, in that countries. So if you can see my screen, there at the left side, there is a structural design drawings. Based on that, we make a 3D model and make a connections and produce a 2D drawing, just like at the right end, the shop drawings to fabricate the steel based on our drawing we produce, and the erection drawing, which is also required to erect the building. Then the concept of structural steel detailing. It is really required to accuracy and what type of the beam columns that need to be fabricated on accuracy level. So steel detailing is came from the past several years, like previously it is did on the board sheets when there was no computer and all. Then it comes with the AutoCAD that you mostly know. The AutoCAD is a manual work, like you can draw everything. But recent we have a softwares that is automatic 3D softwares. So it will be useful for the fast speedy steel detailing. I will show you 2 videos to understand what is steel detailing and how it comes from the raw. So it will be easy for you to understand it more.
These are the miracles of the modern age. Buildings so tall and graceful they defy imagination. Bridges spanning depths of rushing water with powerful girders so slender they seem to disappear into the abutments. These are the miracles we live with and enjoy every day. And they could only have been built from steel. The strength and flexibility of steel is unsurpassed by any other structural material. Steel is light, yet it is strong enough to stretch across great distances with longer spans. Steel gives designers and engineers the ability to fulfill their most imaginative concepts with structures that would be impossible to build with anything else. Steel is not only durable and economical, it allows existing structures to be altered or expanded for new or greater uses. And because fabrication can be precisely controlled off-site, steel is fast to build, much faster than other materials, and it is buildable in any season. Steel also helps preserve the earth because it is 100% recyclable, and it can be used again and again without losing any of its original strength. In fact, more steel is recycled than all other materials combined. Thanks to the power of contemporary electric arc furnaces, this scrap metal can be transformed into high-quality steel in little more than 3 hours. When it has been fired, refined, and processed, it can become powerful beams capable of supporting modern buildings or bridge spans. This electric arc furnace, consuming about 75 megawatts of electricity, just melted about 125 tons of used cars and other forms of ferrous steel scrap in about 60 minutes. The electricity arcs between the carbon electrodes and the steel scrap in the furnace to produce a heat of molten steel. Once the scrap has been transformed into molten steel, specific alloys are added to create steel that has the exact strength and properties required for its future use. Each heat will meet the requirements of the steel specification ordered by the customer, related to the chemistry and composition. Using electronic microscopes and spectrometers, inspectors scan the steel to ensure that every piece of steel has a uniform and consistent composition. Since the introduction of structural steel shapes, improvements in materials and design methods have made a profound difference. If the Sears Tower were built today, it would require 35% less steel than when it was built in 1974. After the scrap has been melted, refined, and tested, the molten steel goes into a bathtub-like container called a tundish. The steel then moves through continuous casters, where it will be made into slabs, billets, blooms, near-net shapes, or beam blanks. In the continuous casters, the steel flows through nozzles into water-cooled molds, where it is cast into a continuous bar. When the steel comes out of the caster, it must cool to 1600 degrees in order to solidify. When the steel is to be rolled or further processed, it will be brought back up to 2400 degrees before it completely cools, thereby saving the time and energy that would be required to reheat steel at a later time from room temperature. This process, like many others in the production of today's steel, is controlled by computer-driven equipment. The steel bar then goes through a straightener, and it will emerge as the finished product. Just think, only a little more than 3 hours have passed since this steel was scrap metal. It has been transformed into high-strength steel, saving our precious natural resources and preserving the earth through the use of recycling technology. After the steel has been produced, every piece of steel in a skyscraper or bridge must be precisely cut, its holes properly placed, its pieces welded in exactly the right location. Every single bolt in the structure must be located and attached at the proper place, and all this must be exact to 1/16th of an inch, so that the steel members will fit together perfectly at the site. That's why a process called detailing is such an important and integral part of building today's complex steel-based structures. It is the detailer who must develop drawings that are so precise that they will show the fabricator the exact dimensions required for manufacturing the finished steel components that will go into the structure. To accomplish this formidable task, the detailer will take the design prepared by the structural engineer and, on paper, build a 2-dimension or a 3D model of the steel frame of the building or bridge. It is from this model that the detailer will generate a complete list of every member in the structure, as well as shop drawings for all the individual steel pieces. To accomplish this process, the detailer must compute the length of the beams and columns, as well as the bolts and raw material to be used. The detailer must also keep track of every hole in the entire structure. If a change is made in a beam connection or in the hole of one column web, it will be up to the detailer to indicate exactly how that change will affect all the holes in those beams. In addition, if a member has been changed on the shop drawing, the detailer must also change the erection drawings that will be used in the field. All this information is developed with the help of computers, and it can be downloaded to the drill line in the shop or to the angle master to show them how to drill holes for the angles. But it's important to realize that although these critical tasks are done with the assistance of a computer, they are not done by the computer. The detailer's training, skill, and expertise is the key to the process. It is the detailer's ability to translate the engineering drawings of a large structure for the fabricator so that the fabrication shop will know exactly what must be done to prepare the steel. The detailer will also indicate the preparation, cleaning, and painting of the materials depending on its specification. If that weren't enough, the detailer may also have to consider and take into account shipping requirements, sometimes even the cranes that will be used in the field, and how those cranes will load and unload members from the truck. Before the fabrication shop actually drills and cuts the steel members, the detailer must submit his shop drawings to the engineer of record for approval to make sure that the shop drawings are fully compliant with the engineer's design. It's clear that steel fabrication plays an important role in joining steel members, even before the beams and girders arrive at the construction site. This is one reason why on-site building with steel is so much faster than is possible with other materials. At the fabrication shop, the steel is cut, punched, and pre-assembled as much as possible according to the detailer's drawings. These drawings can be used to generate computer disks that will drive the shop's fabricating machinery to cut and drill the steel with absolute precision. If cutting is necessary, the operator inputs the size and the desired length of the member. The stock lengths of steel will enter the cutting machine by conveyor. An automatic arm stops the stock at exactly the right point, and the blade cuts the steel. The piece will then be labeled and rolled out. From the cutting area, the steel members will travel on a conveyor to the next station, where holes will be drilled to make the bolted connections. Here again, these critical processes are precision controlled by computer.
So by this two small videos, you come to know what is essential in the steel detailing from raw steel to the erected buildings. So now we come to the importance of the structural steel detailing. Steel detailing is essential for large projects, withstand natural calamities and avoid collapse. So most of the times, it all based on the design from the structural engineer and the architectural. So the durability of the steel structure is good. So it is really important than the concrete building we did in India. Like in US and Canada, most of the parts of the buildings in industrial, in commercial, malls, colleges, all the buildings are made up of the steels with the glass and other architectural trades. Then where is structural steel detailing is required, like pre-engineering building, PEB, like a warehouse, just like you can see in the exhibition center, there are only columns and the roofs. So it calls at the pre-engineering buildings, light metal framing, aluminum curtain walling and facade in industrial industry. Offshores, like we have Bombay High in Mumbai for the industrial oil area, oil and gas. So these all structure in the sea is called as offshore structures. Then bridges with all made up of steel, and the transmission tower for the electricity. So all these steels require the detailing to know the length and width of all the steel members to the fabrications. Then the steel detailing procedure. The first, suppose there is a owner for the buildings, so they will go to the architect. Architect design the plans, elevations, then choose a structural engineer if there is a structural element required based on the loads, live loads, dead loads, all these parameters we check, and then decide for the structural engineer. The engineer will design the building, and then it can be sent to the structural detailer. Either structural engineer choose the structural detailer, or they can choose the fabricator. Most of the time, the fabricator is chosen by the structural engineer, and then the fabricator choose the structural detailer and the erector. So normally, the steel detailing companies is bind with the fabricators. So all these procedures of the steel detailing made up of on the steel detailing softwares, and the final output sent to the fabricators, and then fabrication will start, and then it go to the site and then erect the building. So this is the procedure and the ranking, how the job execute in the steel detailing or on the steel structures. Then now we come to the steel detailing softwares. The SDS2 is the old software used in the market from US, and still it is using for some point of view, and it is offer a highest level of automation and intelligence available in 3D steel detailing. The next is ProSteel, Allplan, Autodesk Advanced Steel. You know the AutoCAD. Previously, the AutoCAD used for the steel detailing, but it is took a long span of time for the single job, because you have to imagine all the 3D view in your mind, and then you have to execute it on the 2D, because AutoCAD was a 2D only. Now the more softwares will come in 3D, and then it will be a simplify the steel detailing. Then the last one is a Tekla, which we are using the most in all over the world. The Tekla structure is started at least at 2000, after the 2000s, and now there is a lot of versions to updating on that softwares to make it easy steel detailing. So it avoids the human error, rework, save the time, because you can easily get. If you can compare AutoCAD and Tekla, then it is the fastest way. Like AutoCAD, you have to draw, but in Tekla structures or SDS2 software, you will get an automatic view of the drawing. So you have to just make it dimensioning, welding, and the sections required. So no need to draw everything. So it saves the time at that point, facilitates smooth communication and coordination between with the help of 3D model, because in 3D you can view and rotate and see where is the conflicts, because some industrial projects are not only about steel. There are piping is involved, electrical is involved, HVAC is involved. So you need to gather all these models into one model, and you can check in the 3D, like if there is a clashing of piping to the steel, HVAC duct to the piping. So you can simplify it and make a questions, and then to avoid the clash, and then you can use as a 3D software there. And the optimization of process and profit maximization. So why is Tekla? So Tekla is easy creation and management of 3D structural models, handle even largest and complex structures like bridges, conveyors, then the tallest buildings. So everything can be possible on Tekla, and it will give you a fast output. So I can share you some projects around the world we did as our Tekla company for this steel detailing. So you can see it is Amazon new headquarters. You know the Amazon online, we can shopping on that. So it's a headquarters of there in Seattle, Washington, USA. At the right side, you can see the architectural view there, and the left side, it is made up in the Tekla structure software. These all colorful steels are being columns. It's the longest tall buildings. We fix it, then we make a connections, and then we produce a 2D drawing. Then the drawing will submit to the customer. They fabricate, and then ship to the site, and then they erect the building. This is the procedure. The next one, it is a Canada, Quebec. It's some industrial projects. So you can make that critical type of project into the Tekla structures. This is one of the in Navi Mumbai, D.Y. Patil University, School of Management. It's all made up of steel. Now, all the floors and everything, below the floor there is a slab, but below the slab there is a steel. All the crowns at the roof, all made up of steels. This is the New York, USA LaGuardia Airport. The same, you can see how the architectural view and how the 3D model view. This is one of the Maui Central Pacific Bridge. So it is all made up of steel, but of course there is a concrete to be used as a slab or the wall. But the columns, beams to support the structures is all made up of steel. This is conveyor, like you know that we can need to transfer the charcoal from one point to another point. So we need a conveyor like that. So it is all the industrial area in the Australia, and they need some structures, and in structures there between a conveyor to pass one things to the another layer, another location. This is the Wankhede Stadium, Mumbai. If you see the left side and right side, all these made up of trusses. So it plays in Tekla structure and make a drawing and fabricate it. So you can do any type of structure in this world in the Tekla structure and the SDS2 softwares. So I just come in the certificate course in structural steel detailing. Actually, we have a head office in the Mumbai and the branch offices in Jalgaon, Nashik, Ratnagiri, Kolhapur, and Goa. So for the newcomers like diploma or the B, actually these Tekla structures or the steel detailings is mostly used for the American and Canadian, European and Australian jobs, not in India. India, you can get only the airports and the stadium for the steel, not the buildings. So just like the IS code in the India, we have to use AISC and CISC, American Institute of Steel Corporation and the Canadian Institute of Steel Corporations. So these two codes we have to use for their jobs. So for the freshers, it will be difficult to understand the steel detailing, their standards and everything, and again the softwares. So in this steel structure field, steel detailing fields, only require the experienced person. So what we can do as a tech flow, we introduce one certificate course of 3 months, which you can learn all types of things like first the placing of steel into the steel structure, the software knowledge, then the modeling of the steel. You can make a connection there, then you can produce a drawing, you can edit the drawing as a draftsman, you can check the drawing for the parameters given by the codes, then you can send the drawings to the fabricator, and then it's a made up of 3-month course that you can learn everything within the course, full-time course, 9 to 6. But in that 3-month course, you have to learn only 2.5 months. After the 2.5 months, there is a 15 days a pilot project, a small project we will give you. You have to execute your own from the starting from placing, connections, editing, checking, erection drawing, everything. And then you have to submit your submittals to the trainer. So trainer will check, and based on your performance and the past 2.5 months, your question answering, everything, they can check your projects, and you will get certificates. So there is a assessment like pre-assessment, mid-assessment, 1, 2, 3, post-assessment, and final examination and certificates. So the certificate based on the gold certificate, silver certificate, and bronze certificates. So actually this is, if there is a Tekla software, it's also a company in India. So we have started this course with the fees because the Tekla structure is a licensed software, and it requires you the training first. So the course fee is like a 1 lakh rupees plus 18% GST. So it is 1,18,000. So what our management decided, we are not just giving you the course with getting money and ask you to see the jobs. We are doing like a job assessment for the 1 year. It means after the completion of 3-month course, you will get job assistant for 1 year. So you will get a stipend for the diploma person. You will get 12,500, and for the BE person, you will get 15,000. 12,500 for diploma and 15,000 for the B. So the course is designed because, like, if you are a diploma, you will get 1,50,000 within the 1 year as a stipend. So whatever you give to us for the training, so you will get it by the stipend plus 1 year experience, because it's difficult nowadays to give you a job as a fresher without knowing the softwares. So you will get it returned with the certificate, 1 year online job experience, and after the 1 year, we will see your performance based on your evaluation within this 1 year, and then we will decide to continue or discontinue based on your performance. If we have to continue, there will be a chances to continue you. If we decide to discontinue, then you are free to get a job in the market, because we already have the course and 1 year experience. So it is really beneficial for those who have a fresher to take the opportunity to learn it, take a job as a 1 year experience, and you are free then. So it is like a steel detailing course. So Tekla Structure, SDS2, and there are AISC and NISD are the two American Institute of Steel Construction and National Institute of Steel Construction. These are two constructions manual, like, so it is a certified course like Tekla Structures. So I can explain all about the steel structures and the steel detailing. Now I will share you one job. So you can see now, this is one of the job of the building in USA, Florida. So this is way outpatient clinic. It's just a clinic. You can see the architectural view of it. So what we get initially from the structural drawing, this is the plan, like a foundation plan. Just, you know, as we made a house in India, there is a plan for the concrete beam, grade beam, then column, concrete column. So in structural steel, there is a foundation plan for the steel. So you will get here all the footings, then the steel column schedule. These are the columns. Then you will have like a roof plans. So it's a roof framing plan. All these steels, there is a call out for the steel members. Just like a grade beam, it is a steel member call out like W14, W15 is different within the country. Canadian having different profile, US different. In India, there is a different. In India, you can call ISMB, ISMC. In Australia, there is a different. In UK, there is a different. So you will get that type of drawing to place the steel into the model. So we have that plans, elevations, and then we made this Tekla Structure software as a 3D model. So this is the software you can know, just like the AutoCAD, but a different one. So the same job I'm showing you in the software. So you can see everything into the 3D. We can place a wall, window, but it is just for the reference. As a steel detailing, there is only scope of steel, not the concrete. We are not doing anything with the concrete. These are joists. It's a lightweight steel that also do by a different trade. We are not doing it just, so we place it just like for the reference. So these are the columns. These are the beams. I'm just showing you. You can see here the bolting connections, the plate it welded to the column and bolted to the beam. You saw that everything into the video that they are erected and bolting. One man is bolting beam to the column. Here is a ladder. This is the canopy. You can see this view. See, this is the canopy. You can see here this one. So now you can see these columns are visible, but the steel, it is not visible because it is covered up by some sheetings of aluminum. So everything is covered by the architectural trade like aluminum wall. This is like a CMU wall, concrete wall, the glass area. You will not see the steel inside it. Then after the 3D modeling and the connections of the bolting welding, we have to generate the 2D drawing. So I'm showing you one column drawings. See, this is drawings that already generated from the Tekla structure as a view only, but all these piece mark, section, dimensions, we have to give it into the model, into the software. If this drawing need to be created on the AutoCAD, then you have to draw all these things, like all these lines of column, dotted, continuous, everything, this hatching. But in Tekla structure, you will get it automatically. You have to do like a dimensioning required section. Like I cut a section A for the base plate for showing the hole. Here is a weld. Here is a hole diameter. Here is a piece mark for the plate. Then the beam drawings. So beam having the hole. What is the dimension for the hole? What is the cut for the beam end? Hole diameter. There is a plate welded. So welded, so how it can be connected or welded or location. So I cut the section A. If you can see the section A, here is the dimension for the hole. Here is the weld. So everything you have to put on the drawing that will be easy for the fabricator shop man to fabricate the steel, the weld steel on the accuracy level. So this is called steel detailing, to receive a structural drawing, make a 3D model, connect it, and then produce a 2D shop drawings, and then the erection drawings. Erection drawing for the erection on the site. So this is all the course and the steel detailing and the software used for it. I'm done with it. Hello, sir.
सर
येस सर.
काही क्वेश्चन्स असतील तर विचारा.
अजून तरी नाही आहेत क्वेश्चन.
सर ह्या ह्याच्यात म्हणजे आता टेक्ला सॉफ्टवेअर्स आहे तर त्याच्यासाठी आपल्याला बेसिक नॉलेज जे आहे ते बोल्ट डिझाईन वगैरे किंवा ह्याचं डिटेल्स मध्ये लागणार की जनरली थिअरी पार्ट्स तुमच्या इथे कव्हर केला जातो?
नाही नाही, हे सगळं थेरी पार्टवर दिलं जातं. नॉर्मली हे सगळं जे स्ट्रक्चरल ड्रॉइंग्स येतात त्याच्यावर पूर्ण इनपुट असतो. फक्त आपल्याला तो 3D मध्ये कन्वर्ट करायचा आहे सॉफ्टवेअर मध्ये. तर त्याच्यावरती बोल्ट डायमीटर, डिझाईन वगैरे सगळं करून येतं. आपल्याला फक्त ते स्टडी करता आला पाहिजे ड्रॉइंग्स, आणि त्याप्रमाणे प्लेसिंग अँड कनेक्शन्स करता आले पाहिजे. तर नॉर्मली सिव्हिल हे फील्ड टोटली सिव्हिल इंजिनिअरिंगचं आहे ॲज अ कन्स्ट्रक्शन पार्ट. पण मेकॅनिकल इंजिनियर्स सुद्धा ते करू शकतात, कारण इथे पार्ट फक्त ड्रॉइंगचा येतो की तुम्हाला प्लॅन व्ह्यू, फ्रंट, टॉप, साइड व्ह्यू याची जर आयडिया असेल जी आपल्याला डिप्लोमा फर्स्ट इयर मध्ये असते, किंवा काही जणांनी ITI करतात तर त्यांना ती व्ह्यूजचं नॉलेज असतं. तर व्ह्यूजचं नॉलेज आलं तरी मेकॅनिकल स्टुडंट सुद्धा हे करू शकतो. तर त्याच्यासाठी असं काही स्पेसिफिक नॉलेजची गरज नाही. आता आमच्याकडे आता 450+ एम्प्लॉई आहेत, तर त्याच्यामध्ये BE भरपूर आहे. पण मग BE मध्ये असं पूर्ण स्किल डिटेलिंग सब्जेक्ट नाहीये की तुम्हाला सगळं माहिती असेल. तर आम्ही ते सगळं कोर्समध्ये कव्हर करतो, आणि जसे तुम्ही वेगवेगळे जॉब करत जाल तसे तुम्हाला त्याची आयडिया येत जाते. सो असं काही नेसेसरी नाही की पूर्ण आयडिया पाहिजे. जस्ट तुम्हाला एक अकॅडमिक सिव्हिल मेकॅनिकल BE डिप्लोमा किंवा डिप्लोमा किंवा बी एवढं तरी सर्टिफिकेट आम्हाला लागतं, जेणेकरून त्यांना ते इझिली अंडरस्टँड होईल.
टेक्निकल टर्म्स ज्या आहेत त्या इझिली
अंडरस्टँड होण्यासाठी. बाकी याच्यात डिझायनिंग नाहीये, हे स्टील डिझाईन हा वेगळा पार्ट झाला, तो तुम्हाला ME केल्यावरती स्ट्रक्चरल डिझाईन मध्ये जात आहे. डिटेलिंग म्हणजे फक्त तुम्हाला 2D ड्रॉइंग बनवायचे आहेत विथ द हेल्प ऑफ 3D सॉफ्टवेअर्स. तर तुम्हाला वेल्डिंगचं नॉलेज थोडंफार पाहिजे किंवा बोल्टिंग, स्टीलचे सेक्शन्स वगैरे, हे म्हणजे थोडंफार माहिती पाहिजे. डिझायनिंग हा डिफरंट पार्ट, त्याच्यामध्ये तुम्हाला ME स्ट्रक्चर केल्याशिवाय त्याच्यामध्ये डिझायनिंग नाही करता. तर आम्हाला डिझायनर, स्ट्रक्चरल इंजिनियर किंवा स्ट्रक्चरल डिझायनर करून पूर्ण डाटा येतो, तो आम्ही फक्त 3D मॉडेल्स मध्ये उतरवून त्याचे 2D ड्रॉइंग फॅब्रिकेशनला देतो. सिम्पल सांगायचं म्हणजे जसं आपल्याला आता एका घरासमोर गेट पाहिजे, तर आपण फॅब्रिकेशन वर्क मध्ये जातो आणि तो त्याच्या हिशोबाने आपण फक्त डायमेन्शन देतो की मला हे तेवढ्या लेंथ मध्ये पाहिजे. तर ऑलरेडी त्याचा एक्सपिरियन्स असल्यामुळे तो ते डायमेन्शन बघून बनवतो आणि आपल्याला देतो. पण जसजसे बिल्डिंग्स चेंज होत जातील आर्किटेक्चर व्ह्यू, तर त्याला ड्रॉइंग लागते प्रॉपर. तर ती ड्रॉइंग आम्हाला स्ट्रक्चरल इंजिनियर करून मिळते आणि ती आम्ही मॉडेलमध्ये उतरून फॅब्रिकेटरला इझी फॅब्रिकेशन करण्यासाठी 2D ड्रॉइंग दिल्या जातात, त्याला स्ट्रक्चरल डिटेलिंग म्हणतात.
मग ह्यामध्ये स्टँडर्ड्स वगैरे जे आहेत ते त्याचं नॉलेज सुद्धा तुमच्याकडनं म्हणजे गायडन्स
ट्रेनिंग मधून दिलं जाईल. कारण हे आता तुम्ही जरी कॉलेजला शिकवत असाल तरी ते IS कोड असेल. तर नॉर्मली आमच्याकडे इंडियन प्रोजेक्ट्स कमी असतात. लाईक मी सांगितलं की फक्त एअरपोर्ट्स आणि स्टेडियम सध्या इथपर्यंतच आहे, आणि काही इंडस्ट्रीयल प्रोजेक्ट आहेत लाईक रिलायन्सचे जामनगर रिफायनरी वगैरे, असे जे इंडस्ट्रीयल येतात तेच फक्त IS कोड किंवा जिंदाल स्टील आहे, तर ते रेअरली आहे. पण मग जर US आणि कॅनडामध्ये आपल्याला काम जास्त करायचंय तर तिकडचे स्टँडर्ड्स वेगळे आहेत, तर ते आम्ही ट्रेनिंग मध्येच देतो आणि ऑनलाईन जॉब करता करता त्यांना ते समजतं. तर त्यासाठी ट्रेनिंग इम्पॉर्टंट आहे.
आणि हे कसं स्पेशलाइज सॉफ्टवेअर आहे त्यामुळे ट्रेनिंग तर जरुरी आहे. आणि गल्फ कंट्रीमध्ये ह्या सॉफ्टवेअर डिटेलिंगला किती आहे?
गल्फ कंट्रीमध्ये पण या सॉफ्टवेअर यूज केला जातो बऱ्याच प्रमाणात. गल्फ काही कंपन्या पण आहेत फॅब्रिकेटर ज्या इंडियामध्ये आउटसोर्स करतात कामं, आणि इंडियामध्ये आता डिटेलिंग खूप वास्ट झालंय. ऍक्च्युली जेव्हा 2005-06च्या आसपास जेव्हा डिटेलिंग चालू झालं होतं किंवा त्याच्याही आधी, त्यावेळी बऱ्याच प्रमाणात कमी मुलांचा कल होता डिटेलिंगकडे ऍज अ BE किंवा डिप्लोमा. त्यामुळे तेव्हापासून आतापर्यंत बऱ्याच गोष्टी वाढलेल्या आहेत आणि कंपन्या पण आहेत लाईक दिल्ली, हैदराबाद, बेंगलोर, मुंबई या मेट्रो सिटीमध्ये खूप कंपन्या अशा झाल्या आहेत, आणि आउटसोर्सिंगसाठी त्यांना US, कॅनडा, दुबई, ऑस्ट्रेलिया सगळीकडनं कामं मिळतात. आणि दुबईमध्ये पण खूप आहे लाईक सौदी, कुवेत, त्याच्यानंतर अबुधाबी किंवा दुबई, इकडे पण बऱ्याच कंपन्या आहेत जे स्टील डिटेलिंग यूज करतात. सो वन्स यू गेट एक्सपिरियन्स, तुम्हाला एखादा एक्सपिरियन्स स्टील डिटेलिंगवर 4-5 वर्षाचा मिळाला आणि तुम्ही त्या सॉफ्टवेअरवर फर्म झाले, तर तुम्हाला वर्ल्डमध्ये कुठेही चान्स मिळू शकतो. US मध्ये पण काही कंपन्या आहेत, जर तसा एखाद्याचा प्रेफरन्स असेल बाहेर जाऊन काम करायचा, विजाचं होत असेल किंवा इतर कंडिशन्स मॅच होत असतील, तर अब्रॉडला पण कामं करू शकतो.
सर अजून काही प्रश्न आहेत का?
हो सर, एक क्वेश्चन आहे. सर, इज देअर एनी सॉफ्टवेअर other than Tekla for steel structure designing?
Yeah, SDS2.
SDS2. Sir, please give us information about that.
Okay, SDS2 is similar as a Tekla structure, but if you can see with the vast variety of the Tekla structure and easy user friendly, most of the fabricators choose it. So Tekla structure is using more in the world than the SDS2. SDS2 is based on the US. So few US states are using, or the few fabricators from the US using SDS2. So they want us to do the job on SDS2. So our course is based on the two software, Tekla structure and SDS2 as well. So our SDS2 software is only running in the 2 offices in Nashik and Jalgaon. So our course conducted on that office only for the SDS2, and for the other offices we are conducting the Tekla structure course. So both are same, but the different perspective like. So it depends upon fabricator as well.
Thank you, sir.
अजून एक विचारायचं होतं की सपोज तुमच्या टेक फ्लो मध्ये प्रमोशन्स आणि ह्या बाबतीत कसं म्हणजे स्ट्रक्चर असतं?
स्टार्टिंग आम्ही आता सपोज कोर्स थ्रू जाऊ आपण. समजा कोर्स कम्प्लीट झाला तर जी ग्रेड मिळेल 90, 80, 70% वर जी ग्रेड आहे तर आम्ही चूज करतो की कोण मॉडेलर बनू शकतो चांगला बेस ऑन ते 3 months वर, कोण एडिटर आहे चांगला, कोण चेकर आहे चांगला. तर त्या बेसिस वरती आम्ही रिक्रुटमेंट त्याची त्या पोझिशनला डायरेक्ट करतो. नाहीतर द स्टेप्स अशी आहे की फर्स्ट ड्राफ्टिंग मीन्स तुम्हाला शॉप ड्रॉइंग आणि इरेक्शन ड्रॉइंग एडिट करायचे आहे. व्ह्यूज क्लिअर झाले पाहिजे की कुठून सेक्शन घ्यायचं आहे, कुठलं डायमेन्शनिंग द्यायचं आहे, कुठला वेल्ड कुठे द्यायचं आहे. तर हे सगळे व्ह्यूज क्लिअर झाले की मग त्याला मॉडेलिंग देतो. मॉडेलिंग इट मीन्स की ते इनपुट स्ट्रक्चरल ड्रॉइंग वरचं 3D मॉडेलमध्ये टाकायचं आणि मेंबर प्लेसिंग करायची. जसं मी आता 3D मॉडेल तुम्हाला दाखवलं तर ते सगळं प्लेसिंग आणि कनेक्शन्स याला बोलतात मॉडेलिंग. तर तो ड्राफ्टिंग नंतरचा पार्ट येतो. तर मॉडेलिंग एक काही वर्षांचा 2-3 वर्षांचा एक्सपिरियन्स आला, चांगला मॉडेलर बनला तर त्याच्यानंतर मग त्याला चेकिंग वर दिलं जातं. मग तो चेक काय करणार तर सेम जे मॉडेलरने मॉडेलिंग केले ते चेक करायचं, जे एडिटिंग केली आहे ते पण चेक करायचं. मीन्स ड्राफ्टिंग अँड मॉडेलिंग बोथ चेकिंग करावे लागतात. आणि एकदा का फॉर्म चेकर झाला की मग टीम लीडर, सो त्याच्याकडे एक 10 जणांची टीम असेल आणि तो एक इंडिव्हिज्युअल जॉब हँडल करू शकतो. टीम लीडरचाही चांगला एक्सपिरियन्स आला तर मग तो प्रोजेक्ट मॅनेजर, म्हणजे त्याच्या अंडर 2 टीम येतील, 2 टीम लीडर्स आणि त्यांचे 10 जण, अशी 20 जणांची टीम येते. आणि मग तो इंडिपेंडंट प्रोजेक्ट मॅनेजर असतो, तो ते रन करतो. सॅलरी वाईज जर सांगायचं झालं तर जशी 12.5 डिप्लोमा आणि 15,000 बीई साठी स्टार्टिंग आहे तशी आमची पोझिशन वाईज इन्क्रीज आहे. मॅक्झिमम लेवल 60-70 हजार पर्यंत प्रोजेक्ट मॅनेजरला जाते. पण त्याला सर्टन टाइमचा एक्सपिरियन्स पाहिजे. काही जण पटकन गेन करतात, काही जणांना लेट लागतो. पण बेस्ड ऑन द रिस्पॉन्सिबिलिटी ते मिळत जातं. जसं एखादा मॉडेलर झाला 2 वर्षात, 2 वर्षांनी टीम लीडर झाला तर त्या रिस्पॉन्सिबिलिटीज पण वाढतील. तर त्या रिस्पॉन्सिबिलिटीच्या हिशोबाने तुम्हाला सॅलरी इन्क्रीज. तर स्टार्टिंग 12.5 किंवा 15 पण एंड तुमचा 60-70-80च्या आसपास असू शकतो विदिन द टेक फ्लो.
आणि इन्सेंटिव्ह स्कीम्स असतात का?
हा, इन्सेंटिव्ह स्कीम पण आहेत आमच्याकडे. ते आमच्याकडे बेस्ड ऑन प्रोडक्शन आहे. जस्ट लाईक की एक टीम आहे 20 जणांची प्रोजेक्ट मॅनेजरची, तर त्याला मंथली टार्गेट दिलेलं असतं. तर ते टार्गेटच्या वर त्याने अचीव्ह केलं तर किती अचीव्ह करतो तर त्याच्यावरती पर्सेंटेजवर त्या टीमला इन्सेंटिव्ह असतो. आता ऑल ओव्हर आमचं ब्रँचेस आहेत तर त्या ब्रँचमध्ये बरेच प्रोजेक्ट मॅनेजर आहेत. बेस्ड ऑन असं नाही की सगळ्यांनाच मिळेल, कोण फास्ट. आता त्याच्यामध्ये रिस्पॉन्सिबिलिटी पण येते, ऍक्युरसी पण येते. इट मीन्स तुम्ही जेवढं जास्त ऍक्युरसीने काम कराल तेवढं तुमचं रिवर्क कमी होईल. रिवर्क कमी झालं तर तुमचं आवर्स कमी होतं. मग तुम्ही त्या आवर्स मध्ये दुसरा जॉब करू शकता आणि प्रोडक्शन वाढवू शकता. तर जेवढं जास्त प्रोडक्शन काढाल, जेवढं जास्त आवर्स कमी कराल त्या हिशोबाने तुमचा टार्गेट जास्त मीट होईल. त्या टार्गेटवर तुम्हाला इन्सेंटिव्ह मिळतात. ते इन्सेंटिव्ह आमच्या 6 महिन्यांनी डील होतो. लाईक 6 महिन्याचा ॲव्हरेज. आता एका महिन्यात कधी कधी असं होतं की एका महिन्यात जास्त पण टार्गेट निघतं तर दुसऱ्या महिन्यात टार्गेटच निघत नाही किंवा बिलिंग होत नाही. तर त्यासाठी 6 महिन्याचा फ्लेक्झिबल टाइम दिलेला आहे की 6 महिन्यामध्ये ॲव्हरेज काढणार. 6 महिन्याच्या ॲव्हरेजवरती तुम्ही टार्गेटच्या वर गेले तर त्या पूर्ण टीमला इन्सेंटिव्ह असेल. मग त्यांचा PM ठरवेल की इन्सेंटिव्ह कसा पर्सेंटेज मध्ये कोणाच्या परफॉर्मन्सवरती कसा प्लॅन करायचा. तर इन्सेंटिव्ह पण आहे प्लस सॅलरी वेगळी. पण इन्सेंटिव्ह असं नाही सरसकट सगळ्यांना, बेस्ड ऑन द टार्गेट. मग तुम्ही असं नाही की उद्या 1 कोटीचा इन्सेंटिव्ह घ्या, 1 कोटी तुम्हाला, का तर तुम्ही टार्गेट मीट केलेलं आहे याचा अर्थ कंपनी पण प्रॉफिटमध्ये आहे. अशा
Can it be used for still trust cultural?
काय म्हणता, ऐकून आलं?
Can it be used for still truss design for cultural hall structure?
Yes, everything, but it is not for design. We cannot design and take a structure. We can make it detailing. So if we get the hall structure design drawings, then we can make it 3D model and produce the 2D drawing. We can do anything. I just show you on the video. There are bridges, trusses, hall, buildings, tall buildings. So anything can be done in SDS2 and Tekla structure.
Okay, thank you, sir. Sir, can you explain the fee structure of courses?
Yes, it is 1 lakh rupees a fee and the 18% GST. So 1,18,000 is a course fee for the 3 months complete course. It's 9 to 6 course, means 3 months complete course. There will not be any work within the course in our branches. So after 3 months, you will be a job assistant for the 1 year. So for now, what I can understand for the rural area, everybody don't have the 1 lakh rupees. So we have also slab there, just like they can submit 15,000, 50%, and the remaining 50% we can deduct it from the stipend as well. So not only the 1 lakh rupees they have to pay right now, they can pay 50%, and then the remaining will be deducted from the stipend till the 12 months. So if, but we need a post-dated check of the remaining amount. So by that way, we have a security that the amount will be in our hand, but all the remaining amount will be deducted from the stipend. So suppose one BE person having a 15,000 salary, so it will be deducted 5,000 per month. So he will get 10,000 stipend by deducting 5,000.
Okay, sir. Thank you, sir. Now concluded. Firstly, I would like to thankful Vaibhav Patil sir for giving us his valuable time and guidance our attendees through his highly informative webinar. I am sure that our audience also enjoy the session and are looking forward for more such opportunities to interact with you. I would like to thank our Honorable Chairman, Mr. Achyut Bhosle sir, as well as our Principal, J. Bhosle sir, the HOD of Civil, Mechanical, Computer, and Training Placement Head for organizing this webinar. And lastly, I would like to thank all the participants for attending this webinar. Thank you, all of you. Thank you, sir.
Thank you.